That's great. In the previous videos, we talked about survival curves and the Kaplan-Meier curve, and sometimes it's very obvious to the eye that two survival curves are very similar or very different. But we need an objective way to quantify the differences between two survival curves, and we can do that with the log-rank test. So that is the topic of today's video, so if you're ready, let's dive in. Okay, so let's start by actually finding out what is the log-rank test. The log-rank test is the most common method to quantify differences between two survival groups. And the test just compares the distribution of time until an event occurs in two or more independent samples. So these independent samples would be your groups. Okay, so what the log-rank test does is test whether there's a difference in the time it takes for an event to occur. And we're really looking at a variable that has a start time and an end time. And this end time, as we saw in my previous video, is when a certain event occurs. And again, that event can be the death of a patient, but it can also be remission or taking your cast off after breaking your arm or finishing a 5K run. Okay, but let's focus on the typical example of a clinical trial. We want to test whether drug A is better than drug B, whether drug A actually increases the survival time of the patients. So our start time is the day the patient got their first dose of either drug A or drug B, and our event of interest is death, so that is our end time. We are interested in the time between the start and the end. And our two groups are patients that were given drug A versus patients that were given drug B. Note that we could be comparing survival between men and women, or between patients with or without a particular risk factor, for example, smokers or non-smokers, patients with BRCA mutation versus patients without it. So that's just how we define our groups. In this case, it's they're differentiating themselves by the treatment they're getting. So we collect data from different patients over 5 years and plot a Kaplan-Meier curve. And in this case, the curves are slightly divergent. It looks like drug A improves the survival time of patients, and if we check the curve at 50%, the median survival time is slightly higher in group A versus group B. But the question is that difference between them significant? For this, we need the log-rank test. Nice. Okay, so before we move on, let's just have a look at the hypotheses in the log-rank test. It is a statistical test after all. So the null hypothesis is that both groups have identical distribution curves. There's not a difference between them. And the alternative hypothesis is that both groups have different distribution curves. In summary, we're testing whether survival curves are identical, overlapping or not, and the test is going to try to reject the null hypothesis. Great, so never mind how you actually carry out the log-rank test, we'll have a look at that later on. But what is the result of a log-rank test? What do we get? Well, as with many statistical tests, we're going to get a p-value. And depending on the threshold we use, our level of significance, for example, 0.05 is very typical, then we can reject or not reject the null hypothesis, right? So if our p-value is actually lower than 0.05, then we can reject the null hypothesis. In other words, there is a significant difference between the two groups. Drug A significantly improves the survival compared to drug B. If the p-value is higher than 0.05, we cannot reject the null hypothesis. In other words, the two curves are not statistically significantly different. So with this data, we cannot say that there is a significant difference between the two groups. But you have to be careful. There could be differences between drug A and drug B. For example, you might have just a very small data set, so you don't have enough statistical power to rule out a real difference between the two treatments and avoid a type 2 error, so a false negative. So you cannot really say that there is no difference between drug A and drug B, but with this data, you cannot say that there is a difference. So you would interpret your p-values as you would with any other test. Great. So how do we actually calculate the log rank test? Right. So since usually we wouldn't be actually doing the calculations by hand, I'm not going to go deep into the maths of it, but I will link some interesting web pages where you can find a step-by-step guide on how to actually do these calculations. But I feel it is important to get an understanding of how it works, so a feeling for what are the maths behind the log rank test. So we're just going to kind of see what the test is actually doing in the background. Right, so the log rank test is essentially a chi-square test. It actually calculates this chi-square for each event time for each group and then sums the results. So in a log rank test, we're basically comparing our observed values with the expected values. And if you're familiar with the chi-square test, you probably recognize this equation. Okay, so let's visualize it directly on the Kaplan-Meier curve. So first of all, we're going to count the number of observed events, and we count the number of observed events for each group separately in each of the time intervals. So a time interval is marked by the event happening. So in the first time interval, for example, there was one patient in the pink group who died and no patients who died in the blue group. And now we need to count the number of expected events. So how can we really know what's expected? How many patients are expected to die in each group? So the number of expected events assumes that the null hypothesis is true and that the survival groups are identical. And if the survival groups are identical and we have 10 patients and the risk of death is 2 out of 10, so for one time interval, 2 patients died, then the expected value should be like 1 patient died in each group, right? So to calculate that, you multiply the number of patients per group multiplied by the risk of death, by the actual probability of dying. And if one group were bigger than the other, for example, if the pink group actually had 6 people, then the expected death rate would be slightly higher than in the blue group. So using this reasoning, we can calculate the number of expected events at each time interval as well. Great, so in the background, the log rank test is calculating this for each time interval and then summing the results. And once we have the total number of observed and expected values per group, we can then calculate a chi-squared statistic for each group. And once we sum those two values, we get a number. And this is the number the log rank test will return. And it is basically a chi-square statistic. So what do we do with this chi-square statistic? Well, we go to our chi-square table, and depending on our level of significance, for example 0.05, and our degrees of freedom, which depends on our scenario, in this case it's only 1, then we can see if our results are statistically significant or not. Nice. So this was an intuitive explanation of the log rank test. Hope it wasn't too confusing, but you don't really need to worry about all that, because when you compute the log rank test, when you calculate it, you will actually just get the p-value directly. So you just want to know how to interpret those results. If the p-value is lower than 0.05, then you can say your curves are statistically different, and probably one treatment is better than the other. Nice! But the story doesn't really end here. Is the log rank test enough? Well, the log rank test can be used to test whether there's a difference between the survival times of different groups. However, it does not give you an estimate of the size of the difference between the groups. Also, if we go back to our example, with the log rank test, we were comparing the survival of a group of patients who were given drug A versus a group of patients who were given drug B. But what about including the age of these patients, or their gender, or the presence or absence of certain mutations? They're important things to consider and to correct for when talking about survival times. And the log rank test does not allow for other explanatory variables to be taken into account. For that, we need Cox proportional hazard survival regression. So that is a story for another day. But I hope you liked this video on the Longrun test. I hope everything was clear. If you liked this video, do let me know. If you didn't, do let me know as well. I'm always open for feedback and ways to improve my content for you guys, so your feedback is really appreciated. And I guess that is it. So have a squid-tastic day and see you in the next one.